Now, let's try class practice 35.1. Given that there are two possible routes for the formation of sulfur trioxide from sulfur and oxygen. This is the first route, route A. Direct combinations of sulfur with oxygen to form sulfur trioxide with have a enthalpy change equal to negative 396.0 kJ per mole. The second route, route B, there are two steps. For the first step, sulfur reacts with oxygen to form sulfur dioxide. Delta H1 is equal to negative 297.0 kJ per mole. This is the second step of route B. Sulfur dioxide combined with half O2 to form SO3 have a value negative 99 kJ per mole. Construct an enthalpy change cycle, very commonly used, okay, to show all possible routes for the formations of sulfur trioxide. Now, please highlight for the formation of sulfur trioxide from its constituent elements. Now, why do I ask you to highlight this sentence in red? Because it is our target reaction. So usually I will write down this target reaction horizontally. That means this is our starting point in drawing the cycle. Now what does it mean? Formations of sulfur trioxide. Formation of sulfur trioxide. That means sulfur trioxide is the product, gas. Formation, that means from its constituent elements, sulfur and oxygen. Bear in mind, keep this coefficient as 1 according to the definition. Therefore, I need to put 3/2 before O2. Now, this is our target. Look at the equation. Look at the sentence in red for the formations of sulfur trioxide from its constituent elements. So please draw this in horizontal direction. Do you understand? This is our starting point, okay? Now, actually, it is route A with delta HA equal to negative 396 kJ per mole. I color it in red. Next, route B. Sulfur react with 1O2. Sulfur react with only 1O2 to form sulfur dioxide. So I point it downwards. Have sulfur dioxide. But something is left behind, remains in excess. Now in this reaction, sulfur react with 1O2, but now we have 1.5 O2. That means we have half O2 left. Bear in mind, you need to balance the equation. This is the first step of route B. Have a value equal to negative 297.0 kJ per mole. Okay, then next, route B. We have SO2 react with half O2 to form SO3. Now, this is the second step. SO2 react with half O2 to form SO3. So point it upwards. Okay, this is the second step, which have a value negative 99.0 kJ per mole. I highlight these two in green so that you can see that they belong to root B. Now, can you help me to work out what is the overall enthalpy change for root B? Overall enthalpy change of root B is equal to negative 297 plus negative 99, which is negative 396 kilojoule per mole, which is equal to the enthalpy change of root A. Do you understand? So that's the answer for class practice 55.1. Now I must emphasize, please stop the video and then try the drawing. Try to color in red, color this root in red, color another root in green or in another color, okay, so that you can see that this is the first root and that this is the steps for root B.